Cool. Let's get started. This lecture is going to be about sockets, and if you did your pitches and you were planning to make a game, you probably heard us talking about sockets, because it's a very important part of live interaction in websites. So whether you're making a chat or you're making a game, live interaction is very important. You want very low latency, and to support many clients being able to interact at the same time with a common, for example, game state, you pretty much need to use sockets. There's really no other way to do it. So hopefully, through this lecture and the next workshop, you'll be able to learn the tools that you need to implement sockets in your website. So just a quick review, and since we've already seen Chatbook before for the past hour, we don't have to go too in-depth. But currently, we have a single chat within our Chatbook that's to all chat. This is to all recipients. And you might, or clearly chat's not solved yet, but it looks like it. And the reason it's not solved is because you have to refresh the page to see new messages. And this is really inconvenient. So the tool that we'll use for real-time Chatbook is called socket.io. This is just one, I guess, implementation of WebSockets. And this is the most common use, I get, used like socket package in JavaScript. So the way we really want Chatbook to work is if someone like Kenny sends a message using the post request /API/message, we want the server to be able to tell all the users or all the clients that are listening in on this chat that Kenny just sent hi. But you know how API requests work. The way it works is a client sends a request to the server, and then the server responds back to the client. But the server can't talk directly to the clients that haven't interacted with it through API requests. So API requests are really one way, at least they're initiated from the client to the server. And servers can't initiate conversations back towards the client, which is the main problem. So again, this is the limitation of HTTP requests. You can't have the server sending data to the client unless a request is made from the client specifically for data from the server. So you might be thinking, well, one workaround to having the server send you information using HTTP requests is to constantly pull the server for new updates. So I can ask the server, hey, are there new messages in the chat? Has someone sent anything? And I can do this really often, maybe every second or even less, to mimic the idea of a live chat. And then eventually, Kenny might send or make a post request, and then the server will be updated, and then at some point, Sammy might send a request and then see that the chat has been updated. And then I guess that's fine, but this is very slow. This requires a lot of requests every second, and in real applications like games or chats, this is really impractical because you're going to have to be moving at a much faster pace. So this polling, you would have to do maybe every 10 times a second or something, and that's just really unreasonable. So the solution is to teach the server how to initiate conversations. And this is where sockets comes in. Again, this is socket.io. Socket.io is the library we're using. And it uses WebSocket, which is solving the problem we just mentioned. And the way you should think about it is we have sort of a connection between a server and a client. We'll call this the socket connection. And once a client logs in or opens a web page, we sort of initiate this connection between the client and the server. So this connection persists. We can think of it as an imaginary string between the two. And we have multiple clients connected to the servers at all times. And what the server can do is they can broadcast a message to the client. Now, there's many options for this, as you'll see. The server can broadcast the same message to all the clients, or they can broadcast a message to individual clients. There's really those two cases, and we'll see how to implement those cases. But at all times as well, the client is listening. So whenever a server does broadcast a message, the client can react immediately to that message, which is why sockets is really powerful for live time like reactions. So in our example of Chatbook, if Kenny posts a message using the /API/message route, then if we have sockets, sort of like connections between each client server pair, then WebSockets allows us to have the server broadcast a message to all the clients that a new message has been posted. So again, what we'll probably be implementing is within this post request, when Kenny makes a post request to /API/message, this is an event that causes the socket event to emit from the server to the clients. Any questions so far about what a socket is conceptually? Okay. So in terms of code, this is what it's going to look like. And this is the server code. So everything on the server side is going to use something called the the socket manager. Now this is code that we've already coded for you. And in fact, I'm going to go to W7 starter just to look at this code and show you real quick. And you can follow along if you want, but you can also just look at this screen. Okay, so we have the server socket.js file inside the server. And just opening this up, we see that all of this has, closed it. All of this is given to you, and essentially all the server socket all the socket manager is like a collection of a few functions that we've defined for you. So this file, server socket.js, is exporting an object containing these 8 functions in it: add user, remove user, etc., which are all functions that we define in the same file. But essentially the usage is when you import the file, you import it as like socket manager. So you would do like const socket manager equals require server socket.js or something. And then you can just use the functions in here by doing like socket manager.init or socket manager.add user, etc. And in this case, to broadcast a message from the server to everyone connected, we use the .getIO function. So getIO is going to take, or is going to like pretty much take all the sockets of the clients. So getIO is going to broadcast to every single client who's listening to the server right now. And then .emit is like what actually emits the message. And there's 2 parts to an emit. One is the title or the event name. This is going to be a string. And then the other is data, which is what you're emitting. So this is usually going to be an object. And I'll go through an example in a bit, but first, this is the server side again. The server emits to the clients, and they emit some event name as well as object tied to that event. And then on the client side, we have socket, and then .on is like pretty much whenever we see some event name, we do some function. So on listens for an event name, and then whatever callback function is passed in is run whenever this event happens. So if these two events are the same, then what it would probably look like is, like for example, if we have two events, or the same event called new pset happening, and if we think of the professor as like the server, then the professor can emit an event called new pset, and then pass in data, which is the pset object, in this emit. And then the students who are all listening to the professor will have a socket.on where they listen to this new event, this new pset event, and then whenever this event happens, they do some function like start working or something. In code, it would look something like this, where we pass in a string to emit, and then we pass in an object to the second argument. And then for the student side, the client side, on some event, we have a callback function, where the argument of the callback function is the data that's passed in the second argument of the server side emit. So this object that was passed in is what the callback function in the client side takes in as an argument. So if we take in the pset as the argument, then we can do stuff with the pset, looking at the fields, like if or while pset.do is not tomorrow, then do something, and then we can access the questions as well. And in our Chatbook setting, if we have our socket manager on the server side emit a message event, which is like when someone sends a message to the chat, we want the server to pass in like what message was sent, so message objects that we saw previously in Chatbook. And now the clients that are all listening can or listen for this message event, and whenever that happens, then we have a callback that would take in this message object and then do something with it. For example, render it on the screen, add it to the database, or something like that. Sorry, not add it to the database, but like render on the screen. Any questions about how this example works? Okay. So I just want to show you an example of like an implementation, just so it's less foreign. So if I check out the end of the workshop that we're about to do, and then look at like the server side. I guess in API.js. So within API.js, notice that we're eventually going to be importing the socket manager from the server socket file. And again, socket manager is whatever is exported from this file, which is just a collection of these functions. So init, get IO, etc. And then whenever we do something like have a message be posted to the server, this is an example of where we want sockets to happen, because like if someone posts a message, we want all our clients to know immediately that that happened. And that's why in the declaration for the post route for /message, we're going to have our socket manager emit the message event that contains the message that was posted. So in code, it literally looks like what it was in the slides. It's just socket manager.getIO.emit, and then the string, that's the event name, and the object that we're passing to the client. And then on the client side, if I just look in the code base for like .on and then message, I can see where a client would be listening to the message event. So yeah, like this is in Chatbook, which is expected because I really only care about the message event within Chatbook. So without knowing too much context of the code, it's maybe a bit confusing, but just looking at this one line, the client is essentially listening to the message event. And then when it receives the message event, it adds a message. And add message is a callback function. Specifically, add message is a callback function that takes in whatever we passed from the server. And the emit part, like the second argument of emit, add message takes in an object like that as the argument to the callback. So that's just what it would look like in code. And you'll really only see these two lines of code related to sockets. There's like socket.on for the client side. There's also, on the client side, there's like socket.on as well as socket.off, which we'll go over in a bit in the next workshop. And then for the server side, it's really just we do like socket manager .init or getIO or like add user, etc. And if you control Shift F for a socket manager, you can see all the places where we end up using like the functions that are defined in socket manager. Okay, but that's enough looking into the code, since we'll be looking at it anyways next workshop. Just recapping the Chatbook front-end design. Eventually, we want the Chatbook component to have both the chat list and the chat as children components. Right now, it's just the chat. We don't see like a chat list on the left that we've seen in like the diagrams or the images, like here. And then the chat list is going to display all the single users, or which are those like buttons that you can click to toggle the chats. But yeah, like looking more into Chatbook, we have the chat list on the left and then chat on the right. And then within chat, we've already implemented this, having the single message components up here and then the new message component down here. And then looking at chat list, we have single users being displayed here, which are all the active users who are connected to Chatbook. So if you were pulling up weblab.is/example yesterday, you saw like every time a user logged in, or whenever a client initiated a connection with the server, you could actually see their name pop up on the left because they were added to like the list of total active users who were connected to the server. And yeah, so the main places where we're going to be using sockets is in the chat, so that when a message, when a user sends a message, all the recipients of that message will be notified. And then we're also going to be using it in the chat list. As I just mentioned, whenever a user joins, we're going to be able to see their name pop up in the left in this list. And then for the backend, we have two primary routes. One is /chat, which gets the chat that between a user and a recipient. Right now, it's just getting the chat for all chat. We're going to change it so that we can have like, or get the chats between like you, the user, as well as one individual person, so DMs. And then the post route for /message is just going to send a message to not everyone, or it could be everyone, but also it could be between you and a specific recipient. So this is pretty much the same as what we had in Workshop 6. We're just going to be making the functionality to do stuff only between you and a single recipient instead of all chat. And then for like getting the chat between like you and a recipient, we're going to use like the recipient ID field when we pass it into the GET request. So this is going to be accessed using like rec.query.recipient_ID is 25. And then post, again, is just we take rec.body.content is like the value of the message. OK. Feel free to look at weblab.is/chatbookdocs for more information about Chatbook, like the types that we're using, as well as the routes that we've created. But yeah, after lunch, which is going to be now, we'll be doing Chatbook with sockets to have real-time communication. And before that or during that, if you open up weblab.is/socket guide and /socket docs, you'll find some pretty helpful information or documentation. And I think to start off, weblab.is/socket docs is probably more useful. This essentially just shows you like all of the server-side functions that you can do with the socket manager, and then as well as like what you do on the client side for sockets. So socket to on is like the primary thing that you'll look at. OK, but yeah, that should be it for the lecture. I think Lucas will come up here for food announcements. Please fill out the feedback form. Thanks.
All right, guys. Today we have Domino's, so you guys already know the drill. Please fill out your registration from weblab.is/portal. Please eat outside, and yeah, I think that's it. There's vegan and vegetarian options on the right side.